Hello everyone, I am Sakshi, and next we will be discussing the last four data analysis methods in the rough set exploration system. So the four methods are data decomposition, KNN classifiers, LTF classifier, and the last method is cross-validation method. Data decomposition. Data decomposition tree is a special form of classifier in which the subsets of data in the leaves of decomposition tree are used for calculation of the decision rules. Data in the leaf is selected by the algorithm in a way that all objects it contains belongs to the same decision class. This set of objects is used to generate rules. Here we have an example of a data decomposition tree. As you can see, the data is divided into many different levels, which is also known as leaves, and the data in each leaf is similar, and this is what will be used to generate the decision rules. Next, we have the KNN classifiers. So KNN, which is also known as K nearest neighbor, is a classification method that does not require a separate training set. So necessary steps such as initialization and parameter setting are done at the beginning of the classification test. So to classify objects, user only has to invoke the classification/test table button from the tables menu. A user must have a non-empty table object that will be used as a training sample. The algorithm constructs a distance measure based on a training sample. Then, for each object in the tested sample, a decision is made based on how far the training object is to the tested one. This is a visualization of what a KNN classifier is. Here you can see the test sample is divided into many clusters, and this is based on the training sample, and essentially how far the tested sample is from the training sample. Next, we will be discussing the LTF classifier. LTFC is based on artificial neural network architecture. It is a training process based on slight alterations of network structure and parameters made after the presentation of each training object. So the four alterations include coordinates for the center of Gaussian functions, correcting the width of Gaussian function for each hidden neuron and each component of the input independently, adding new neuron to hidden layer, removing redundant neurons from hidden layer. The last method is the cross-validation method. The dataset is first split into several equal in size disjoint parts. Then one of the parts is taken as training sample and the remainder, which is the sum of all parts, becomes the test sample. The classifier is constructed with the use of training sample and its performance is checked on the test sample. These steps are repeated as many times as there are data parts so that each of the parts is used as a training set once. The result is the average of scores from the previous step. Here is what the result of a cross-validation method will look like.